Good morning, everyone, and welcome to the briefing on the second round of the Commercial Development Program. Let me introduce the people that are sitting on my left, our briefers. Phil McAlister is the Acting Director of NASA's Commercial Spaceflight Development at NASA headquarters. Ed Mango is the Program Manager, NASA's Commercial Crew Program here at KSC. Rob Meyerson, the Program Manager for Blue Origin. Mark Sirangelo, Program Manager, Sierra Nevada. Garrett Reisman, Program Manager for SpaceX. And John Elbon, the Program Manager for Commercial Crew Programs at the Boeing Company. We'll begin the briefing with Phil McAlister. Phil?
Thanks, Mike. First, I want to acknowledge the great work done by the people who designed, built, prepared, operated, and flew the space shuttle for over 30 years. I believe the shuttle is an inherent part of the pride we all feel as Americans, and it is the reason why I'm sitting in this chair today, actually. On August 12, 1977, the Space Shuttle Enterprise flew on its first flight by itself during one of its approach and landing tests, and a picture of the Enterprise was splashed across the front page of my hometown newspaper, thanks to the media. And I thought it was the coolest thing I'd ever seen, landing on the runway, and it was then that I decided to become an aerospace engineer. But like the saying goes, all good things must come to an end. While we are ending the Space Shuttle program, we are not ending the nation's human spaceflight program. It is evolving into an exciting new paradigm of commercial crew operations to low Earth orbit. This evolution follows a pattern where the government initiates an activity which is then followed by the private sector. We have seen this pattern historically in other modes of transportation. For example, the early airmail contract spurred the modern-day airline industry, and the railroad industry was initially enabled through government legislation and investment. The commercial crew paradigm shift represents a similar shift in scope and requirements to the private sector, freeing NASA and NASA's limited resources to pursue other exploration-driven capabilities. It will also feature a fixed government investment and a requirement that the industry partners invest some of their own capital into development. And another key aspect of the program is competition. That's why you see 4 people up here at the podium today. Competition is very central to our strategy. It incentivizes performance and encourages cost effectiveness, and it also does not require NASA to be solely reliant on a single provider. There are many challenges ahead, technical, financial, and cultural, and success is not assured. Both NASA and our industry partners are going to have to change the way we do business in order for this program to succeed. But the benefits of this new approach are clear and compelling. It will ensure that U.S. astronauts will be transported to and from the International Space Station on American-made spacecraft, thereby limiting our reliance on foreign systems and providing assured access to the International Space Station. It will allow NASA to concentrate our limited resources on exploration beyond LEO. It will benefit the U.S. private industry by strengthening our industrial base, enhancing our capabilities in a new high-tech industry, and it will open up new markets for customers other than the U.S. government. But most importantly, it will reaffirm the U.S. leadership in space. Later this year, the shuttle will be retired, and with it, the means for the U.S. to transport astronauts to space. At that time, only Russia and China will have the capability of getting people into low Earth orbit. This represents a very real and significant threat to U.S. leadership in space, and something that has been unquestioned since Neil Armstrong and Buzz Aldrin took their historic steps on the moon over 40 years ago. Well, Commercial Crew will end the gap in U.S. human access to space. The recently enacted 2010 NASA Authorization Act clearly established Commercial Crew as the primary means for U.S. access to the International Space Station, and as such, the Commercial Crew program is the nation's primary strategy for ending the gap and eliminating the threat to America's leadership in space. But most importantly, the Commercial Crew program is not only good for the United States. I personally believe the program will benefit all of humanity. We have seen how tenuous our human spaceflight endeavors can be. We cannot have the future of human spaceflight completely dependent on the prevailing political winds or partisan concerns. By pushing the boundaries of private enterprise and commerce into low Earth orbit, we will have planted the first truly sustainable flagpole in our expansion into space. There will be no turning back. Once commercial human spaceflight into low Earth orbit is a robust, vibrant, profit-making commercial enterprise with many providers and a wide range of private and public users. This is the ultimate goal, and one that I believe unites us all. That's it, and with that, I'll turn it over to my colleague, Ed Mango.
So good morning, everybody, and welcome to Florida. I'm glad you all are here. You know, our nation's leadership in space can easily be displayed by what is at the pad just 3 miles from here. It's a magnificent machine, but the machine is not what the most important part is. It's the people and the intelligence that went behind that machine that makes that machine fly. And so the Space Shuttle program is clearly a key part of what leadership in space is all about, and has been a premier part of what leadership is for America. I think the spaceship itself and the crew that's going to go fly on this next mission are examples of what we are capable of doing, what we're capable of overcoming, and what we're capable of doing in space, and what we're also capable of leading. The next, this space shuttle mission and the last space shuttle mission will end an era of space shuttle, and will end the era of the shuttle being the key leadership role of trying to get humans into low Earth orbit. The next phase of that is the commercial crew program. Another great example of leadership in space is the International Space Station. It's a fantastic laboratory in space led by the Americans, with many other countries helping, but it was that American leadership that got the ISS into space and is operating the ISS today as a lab for the entire planet to use. Our nation will continue to be leaders in space, and I do believe that the commercial crew program will be the method by which we close the gap and continue our leadership in space, at least for low Earth orbit. Today we're kicking off our CCDEV2, as we call it for short, our Commercial Crew Development number 2 program and activities. Our nation's next step will not just be a NASA internal thing, or a NASA setting a contract and letting folks come to try to work on that contract. We're doing this truly as a partnership. We want innovation and we want a partnership, and that's why there's 4 companies involved in the CCDEV2 activity. It is an activity to get a crew transportation system to low Earth orbit. That is what we're doing, and it's an American system. It is not just done here in Florida or any other specific spot in the country. In fact, I think I have a chart if I can get it up, and it shows clearly that the commercial crew activities for CCDEV2 are spread across the country. We really cover all 4 corners of the country and many states in the middle. It is not just a single entity in a single location. These 4 companies have themselves spread throughout the country, and other partners that they're working with spread across the country. So this is truly a national endeavor in order to keep the gap as short as possible and to keep our leadership in space. Like I said at the beginning, the Space Shuttle program is really made of people that are flying that magnificent machine and getting that machine to work properly. It is the nation and the people of the nation that will make the commercial crew program and the crew transportation system work and be successful. I'm very excited, and my team is extremely excited, to be part of what will keep America as the premier nation for space leadership. I'm now going to invite Rob to talk a little bit about his particular portion of CCDEV2.
Okay. Thank you, Ed, and thank you, Phil. I'm Rob Meyerson. I'm the President and Program Manager at Blue Origin up in Kent, Washington, and I'm going to talk to you about our CCDEV activities. I'd like to follow up on the theme that Phil and Ed brought out. Is I worked on Space Shuttle early in my career, and I'm extremely proud of the accomplishments of that program. And the reason I'm here is because of Space Shuttle and Apollo. I mean, that's the reason I think we're all here. Two activities. Give you a little background on Blue Origin. I'll be hard-pressed to fit it all into 5 minutes, so bear with me, but thank you. And let's go to the first chart. Second chart, I'm sorry. Blue Origin's a privately held company. It was founded in the year 2000 by Jeff Bezos. I've been with the company for 8 years. It started out with a very, very small group of people, and our focus has been consistent over this time. We're developing vehicles and systems and technologies to provide safe and affordable human spaceflight. Jeff has a long-time passion for space, and he's brought that to bear in terms of in bringing Blue Origin from a very, very small company to where we are today. We're developing a crew transportation system that's comprised of an orbital space vehicle and a reusable booster system that will take humans safely and affordably to and from low Earth orbit. And the space vehicle is designed to fly on multiple boosters, including the Atlas V, in addition to our own reusable booster system that will follow the flights on an Atlas V. Our incremental development program that approach uses suborbital tests to retire development risk, and that's how we intend to step our way towards human spaceflight. So let's go to the next chart, please. As I mentioned, we're a small company. We're based in Kent, Washington. We've spent quite a bit of money putting the facilities together, the equipment, and building the team and the tools to take on this endeavor. Our Kent site is about 250,000 square feet on 25 acres. We have our own rocket engine test facilities at that site that we've developed, and then we also have our own privately owned launch site out in West Texas. It's about 2 hours east of El Paso. It's a 33 square mile site on 165,000 acres of private ranch land, and we built that site from a greenfield, and we've flown our first iteration of our suborbital vehicles at that site. We can go to the next chart, please. That suborbital vehicle I'm talking about is the New Shepard program, and we kicked this off in 2005. And that program consists of a suborbital propulsion module, which is essentially a reusable first stage that takes off and lands vertically under its own power, and a crew capsule which launches on top of the propulsion module, carries the astronauts to and from suborbital space, brings them back. So you get a short amount of microgravity time. We're targeting space tourism, suborbital science, and other technology missions. Both of these vehicles are fully reusable. They return to the West Texas launch site for reuse. And we began that program incrementally with our first flights of a vehicle we called Goddard, which is shown in the lower right photo. The Goddard vehicle was used to demonstrate our technology for vertical takeoff, powered vertical landing, our concept of operations, and some of the technologies that'll fly on the suborbital vehicle in the future. We can go to the next chart, please. During CCDEV-1, we were one of the five winners of agreements under CCDEV-1, and we worked through that program and successfully accomplished all of our milestones, and we're very proud to have done that. The two projects we worked under CCDEV-1, one was the development of a composite pressure vessel, and that's shown in the right photo. And what we did is we assembled our composite pressure vessel for our suborbital vehicle. This program was ongoing when CCDEV-1 started. We assembled that vehicle, we proof tested it, and we drop tested it to demonstrate basically a hard landing, verified all of our loads, our design parameters. I've heard people comment on the purple nature of that. I'd like to say it's a tribute to the Washington Huskies, but it really is an artifact of the manufacturing process, and so but that's our the composite pressure vessel during that stage of assembly during the CCDEV-1 program. We also developed our pusher escape system, which is a technology we're developing in-house. We tested the escape system using a solid rocket motor developed by Aerojet. And our tests, one of our tests is shown there in the photo at the bottom of the chart. We conducted 2 ground tests, and we demonstrated the side force and the life of the materials of the escape system under a full mission duty cycle type test. So let's go to the next chart, please. Under CCDEV-2, we have 3 projects. One is maturing the design of our orbital space vehicle, and there's several items we have in that task. Completing key subsystem trades. We're going to be working on our thermal protection system with NASA Ames. They're NASA's Center of Excellence for Thermal Protection Materials, and we're happy to have them on our team. We'll be defining the biconic shape, which we've selected for its mid-lift to drag ratio. Provides lower entry G loads than a capsule, but it provides more landing opportunities. We'll be refining that design with aerodynamic analysis and wind tunnel testing. We're going to be developing the interface between the orbital space vehicle and the Atlas V vehicle, working hand in hand with United Launch Alliance, who is another member of our team, and then we'll be completing two reviews for the program: the mission concept review and then a system requirements review, which are the 2 first reviews in that design process. Let's go to the next chart, please. Our second project is to continue the work we started under CCDEV-1 on our pusher escape system, and We will be conducting additional design efforts, and that project will culminate with a pad escape test of our suborbital crew capsule using that pusher escape system. The third project is accelerating our booster engine development, and we are developing our own liquid oxygen, liquid hydrogen booster engine, and we'll be testing that thrust chamber at Stennis Space Center, and we're happy to have Stennis on our team, and we'll be testing at one of their existing stands. That engine is designed to do deep throttling to support our vertical takeoff, vertical landing technology. And the next chart, please. In summary, we're committed to developing safe and affordable commercial human spaceflight. And the suborbital system, the New Shepard system that we've been developing, is designed to prove out the technologies before we commit them to orbital spaceflight. So it's an incremental development approach that we've been taking. It's a long-term vision, and we're focused on executing that. The CCDEV-2 projects were proposed because they help us to accelerate orbital capability. So we can use this suborbital program in some of the aspects, some of the projects, to demonstrate these technologies before we commit to an orbital development, and then we can conduct the maturation of the space vehicle design during CCDEV-2 to work with NASA and the experts at NASA to help to develop that. Finally, I want to thank NASA and our NASA team. We'll be working closely with Ed Mango, Brent Jett. Bill Lane is our partner manager. We're looking forward to working with them on this. We're also looking forward to working with our NASA team partners, including Ames Research Center and Stennis Space Center, and of course the other technical experts within the agency who we know will be coming to our reviews and participating, and we look forward to reaching out and working with you and partnering with you to develop the best system possible. So thank you. And now I'd like to introduce Mark Sirangelo from Sierra Nevada.
Thank you. Good morning, and thanks for coming out. One of the aspects of being part of the commercial crew industry and part of the space industry is that you have to be flexible. And for some reason, our slides got corrupted, so you're all going to have to look at me for the next 5 minutes and write really good things about me. And we're going back to the low-tech world of things. Here's our slide. Everybody gets to look at this slide and write a lot about it, and over the next 4 minutes you'll get tired of seeing me. So thank you for your patience, and this is one of the things I drew the short straw this morning. So my name is Mark Sirangelo. I run Sierra Nevada Space Systems, and I'm really thrilled to be here and be part of this. It's an amazing feat to be standing here. And before I get into my talk, I'd like to this space is a very small community, and those of you who've covered the news this morning realize that there's been some really terrible things have happened in the Southwest and in Alabama, and I wanted to send our thoughts out to our friends in Alabama and in the space industry who are going through a pretty rough day while we're enjoying this really wonderful moment. So for all of us, I think we want to send our best wishes and hope things recover very well for you. Sierra Nevada is a company that many of you may not know. We have been around, though, since the 1960s. The company is approaching its 50th anniversary. It's been under the same ownership and management since the 1990s. We have about 2,200 people working in 20 states, and our space business, though quiet, has been in operation now for 22 years. We've had over 400 successful space missions, and over 5,000 things that we have built and developed have gone to space successfully over the years. We operate throughout the country in a number of facilities, and we've really been proud of this effort. Our program, which you see on my very high-tech slide here, is something called the Dream Chaser. It is a lifting body. It's a 7-crew vehicle that has actually its origins in NASA, starting back in the late 1980s in a program called the HL-20, which developed for about 8 years. Is one of the most developed and tested programs that NASA worked on. And originally, the vehicle was meant to be the lifeboat for the space station. We took that program and began working now about 6 years ago on our program. So in total, there's been almost 14, 15 years worth of very advanced development on the effort. The vehicle is a lifting body taking off vertically and landing horizontally. It has a number of really key attributes that we think are quite good for this program. It has the ability to be a reconfigurable vehicle, so it can take all crew, it can take cargo, it can take critical cargo. It comes in and lands on a runway. We carry no hazardous materials on board. So the ability for our vehicle to come into and be accessed immediately upon landing is a very important element of what we're trying to accomplish. We have, in the CCDEV-1 program, we were the largest award winner in that program. And over the course of the program, we decided to focus our efforts on working on specific hardware tasks that really move things forward. In the course of that program, we built and tested our flight motors throughout the entire flight profile for the operation. If you get a close-up of our vehicle, you will see that it carries onboard propulsion. And that onboard propulsion allows us to have really flexible ability to abort. And in fact, we have no black zones on our abort system all the way through to orbit. And we also have the ability to maneuver the vehicle while we're in orbit. Beyond the motor testing that we did, we actually began and built the first engineering test article. So the first vehicle is under production for us, and it is something that we have really been working hard on doing, because we believe in our business that hardware development should go in hand with the software development and the preparation work that we're doing for the next phase. We're quite proud of being able to have won a significant award under the CCDEV2 program. And under that award, what we're essentially going to be able to do is take this vehicle and bring it to atmospheric flight tests. So we will actually be able to take the vehicle up and test. And in fact, we have built a scale model of the test of the vehicle and tested it in December with the wonderful help from the NASA Dryden Centers, and conducted a very significant series of flight tests from high altitude down in landing and reuse of the vehicle. We're also moving forward on being able to do all work, and we'll take the vehicle through the PDR stage by the end of the cycle in the CCDEV2 award process. I wanted to conclude, if I could, by expressing our appreciation to Charlie Bolden and Lori Garver and all those at NASA. This has been a really tumultuous time in the space industry. Those of you who covered it know, and it's a really difficult time. And I'd like to tell you a bit of a story, since I don't have any more of my slides to bring out. I think many of us are in this industry because we have a passion for it and we believe in what we're doing. And I had the recent ability to go through the Smithsonian Air and Space Museum, and I go there very often when I need time to think and to develop my thought processes about the future. And one of the things I noticed there was really three things in total. The first being that when you look up in the building, you see a lot of firsts, a lot of people who have done pretty amazing things. You wonder what would have happened in the past if the Wrights and Curtiss and Goddard would have been told, well, you can't do this, it's not possible, you'll never be able to make it, you won't be able to get the funds. We believe that we can do that. And I also noticed those vehicles are sitting alongside of many of our heritage programs. There's no reason that what we do can't work hand in hand together with the past of NASA and where they are now. I've heard and read many times in the last week about the end of the Space Shuttle program. From my perspective, I don't see it as an end. I see it as a beginning of the next step. I think Space Shuttle was a bridge to move forward. Our vehicle is based in large part on the successes, on the triumphs, of the challenges, of the pain that was been done in the Space Shuttle program. And on behalf of my team, who I believe I have the best team in the country working on this, I'd like to express our appreciation not only to the leadership in NASA, but to the men and women who have worked through this program to make this possible. We would not be here if those people didn't do what they did, and everything that we're doing in our vehicle, being that we think it's the emotional connection back to the Space Shuttle, is really been based on their success. So to all of you out there, I really do appreciate it, and on behalf of all of us, we thank you for your efforts and look forward to being that bridge continuing into the future. I'd like to turn it over now to Garrett from SpaceX.
Thanks, Mark. My name is Garrett Reisman. I'm representing SpaceX. And SpaceX was founded back in 2002 by Elon Musk. And we've grown very rapidly. We now have over 1,300 employees. And we've been working very hard. But the company was founded originally with the idea to advance the cause of human spaceflight. That's the whole purpose of our existence. And it's actually this opportunity now to take this next step as part of CCDEV2 that not only takes us along our founding vision, but also is also the reason why I left the astronaut office and joined up with SpaceX to help in any way I can. And so now I'm here to talk to you about CCDEV2. CCDEV2, our program, is basically taking our established rocket to the next step. And I actually brought my rocket with me, so if you bear with me a second. It's not the real one. This is not actual size. I don't want any miscommunication there. But the Falcon 9 rocket and the Dragon spacecraft have both been built and flown. The Falcon 9 has flown twice, and the second time it launched, it carried the Dragon spacecraft into orbit, orbited the Earth 2 times, splashed down in the Pacific Ocean, and it was the first time a private company had brought back and successfully recovered a spacecraft from orbit. So we're very, very proud of that, and basically we're taking it to the next level. Now this is something we've been planning for a long time. The Falcon 9 rocket and a Dragon capsule were designed from day one to carry people. So when we built the Falcon 9 rocket, we had all the requirements in mind for human rating, and when we built the Dragon space capsule, it's the same thing. It's under contract, and we've built this in partnership with NASA, with a lot of support from our NASA partners. And the idea is to use this rocket and the Dragon spacecraft to supply the space station. And that's part of the COTS CRS program, which are proceeding along. We'll have the next launch coming up later this year. So on our next launch, we intend to take the Dragon all the way to the space station, dock it, unload it, and bring it back. So it takes cargo. But one thing about it, if you look at the capsule, not this one because it's too small, but if you look at the real one, it has windows on it. Now, I've never met any cargo that has to look out the window. So the idea from the very beginning is a very graphic demonstration that we intended to put people on there. So CCDev2 for us is all about everything we need to do to take what we have and get it ready to actually put astronauts inside of it. And so with that, what I'd like to do is show you a little video, which I think will give you a better idea of what we have in store.
If there had been people sitting in the Dragon capsule today, they would have had a very nice ride. There's only one major development item, and that is the launch escape system. We're going to build the escape entrance into the sidewall of the spacecraft. You'll actually be able to have escape capability all the way to orbit. Even the Apollo didn't have that. Also, because you don't have to release the escape tower every time, you don't have that as a necessary thing that has to occur with every flight. Capability is the very reason SpaceX was founded. So we will do whatever we need to do to make this happen.
So if you like that video as much as I did, I was told to tell you you can see it on YouTube on the on the SpaceX channel. So please tune in. So to give you a little more specifics of what you just saw on the video, during our CCDev2 project, over the course of the next year, our focus will be that launch abort system. And the designing and developing and testing the engines, the tanks, and all the related components for that propulsion system will be our main focus. In addition, we have to design all the systems that go along with that, the abort modes, triggers, boundaries, doing the risk assessments and safety and mission assurance work that needs to be done. And then we'll be working on crew accommodations. So we'll be looking at seats, suits, displays, controls, life support systems, everything astronauts need inside the Dragon. And that will be the focus of our efforts. We have a lot of work to do, but we have a lot of great partners and a lot of help from NASA, which we appreciate. And we look forward to getting ready to put people in the Dragon. Thank you very much.
Okay.
Oh, I'm sorry. This is John Elbon from Boeing.
Great, thanks, Garrett. Good morning. It's exciting to be here. It's exciting to be a part of this group. We're certainly looking forward with the opportunity to partner with NASA as we build on what we've done from Apollo shuttle station and leverage that into this next phase of human spaceflight. So this morning I have a couple slides to show you the system that we're working on, a little bit of what we accomplished in CCDev 1, and then our plans for CCDev 2. So if we can have the first slide, please, and the next slide. So this is the integrated system that we are developing. We're focusing on the design of a spacecraft that will be flown on a proven launch vehicle. Currently we're in the selection process of going through the procurement of that launch vehicle. It will launch from KSC rendezvous with an orbiting platform such as Space Station or Bigelow Space Complex. It can stay on orbit for up to 6 months to serve the lifeboat function. After its time on orbit, it will then deorbit. The service module is discarded during re-entry. We land on parachutes using airbags on land. The capsule is reusable for up to 10 missions. It's our design point. And then importantly, an integrated piece of this system is a mission control center and the ground processing capability. So as we've worked through CCDev1 and on through CCDev2, subsequently completing development, we'll be focused on this entire integrated system as a turnkey capability. Next slide, please. This is the schedule that we're working to. Colored in is CCDev1. During that phase, we took the design of the integrated system through Systems Definition Review, SDR, and that was completed last November. As we start into CCDev2 now, we'll be working through PDR, part of the way towards PDR's preliminary design review, and then part of the way towards the critical design review. There are 4 test flights that are part of our program. Pad abort test that is scheduled in 2013 to test out the abort system, just launching from the ground. And then 3 flights that will use rockets, one that will be an orbital flight test that will put the spacecraft into orbit. It'll operate for a couple days in orbit uncrewed and then re-enter. An ascent abort test that will test the abort system at maximum dynamic pressure, max Q. That's the stressing case for the abort system. And then finally a 2-crew flight test that will happen in early 15, and then we'll be ready for operational readiness later in 15. So those test flights are part of our schedule going forward. The design of our spacecraft is, we're really focusing on keeping it simple, and that's for several reasons. As Phil mentioned, this is an environment where NASA's investment is fixed, and so we need to really control the risk that we have during the development phase. And so selecting technologies that are high TRL allows us to manage that. In addition, having a simple system makes it safe and reliable, and it helps us to keep the operational costs low. So those are really the focuses of our design as we move forward. Okay, next slide, please. These are the teammates that we have as part of our CCDev2 team. Airborne Systems will be working on parachutes for us. Ares is doing some, Ares is a company in Houston, strong background in safety type disciplines, and they'll be helping us with loss of crew, loss of mission risk assessments. We've been teamed with Bigelow through CCDev1 and now through CCDev2. A lot of our testing is done at the Bigelow facility, work on mock-ups, and as a user of our system, also helping us define the requirements. ILC Dover is working on the landing system airbags. Pratt & Whitney Rocketdyne is working on the abort system, the engines associated with that, and the tanks and the integrated system. Spincraft is a provider of the spun-formed domes that we use to build our pressure structure out of. And finally, on the list here is USA, who will be helping us with some flight ops and training activity. In addition, we are teamed with Bigelow and Space Adventures as potential users in the future, and so they're helping to define the requirements of our vehicle as we move forward. Next slide. Just some of, in summary fashion, I'll show you some of the accomplishments during CCDev. The biggest one, as I mentioned, was we took the design through SDR, a lot of effort in that, and then these are some of the demonstrations we did. About 20 drop tests using the airbags to demonstrate how that system worked. Some uprighting tests in a contingency. We land in water. Capsules have a condition called stable 2 where they can be nose down. The uprighting test showed that we could upright from that condition. Integrated the life support system to verify we could handle the metabolic load of 7 crew. And then built the crew module mock-up so we could have the crew help us with positioning panels and that sort of thing. More demonstrations on the next slide. If we can switch the slide here. Having an inexpensive heat shield is important to our model because we discard that each mission, so we did some work on new material, new manufacturing process for low-cost heat shields. We fired the abort engine. It's an engine with a lot of heritage. It's used with a different fuel for our system, so we fired it with that fuel and it performed well. We fabricated the pressure vessel structure. Very innovative approach here of building a structure. It has no welds. It's got one joint that is bolted together. It's constructed out of two spun form pieces. Another innovation that helps with affordability. And then finally we integrated the automated rendezvous and docking system, which is based on the Orbital Express system that demonstrated on-orbit automated rendezvous and docking. And that's all working well. We'll continue this through CCDev2 on the next slide. Importantly, we'll take the design maturity through preliminary design review and then some amount past preliminary design review, but we'll go through a couple of design analysis cycles, some subsystem preliminary design reviews, and then finally the integrated system preliminary design review. And then we've got 13 development test plans. 6 of those we pulled out as demonstrations that will be included as milestones in CCDev2. Pratt & Whitney Rocketdyne is developing a lightweight version of the abort engine. We'll fabricate that and fire it. More landing bag air drop tests. This time we'll add horizontal velocity in addition to vertical velocity so we can simulate landing on parachutes. We'll be doing wind tunnel testing initially with the spacecraft as shown there, and then once we select the launch vehicle we'll add the launch vehicle to those wind tunnel tests. We'll be doing some parachute drop tests, including deploying airbags and landing on the airbags using parachutes. Expelling the fuel for our abort system is a significant thing. We have to expel all that fuel in 3.2 seconds, and so we'll be doing demonstration of the pressure tank's ability to do that. And then finally, once we select a launch vehicle, we'll be integrating the emergency detection system of that launch vehicle with our launch abort system to verify that those avionics can communicate. So a lot of work planned for CCDev2 going forward. Next slide. Now this is really our mantra here as we go forward. All of our design is focused on delivering a safe vehicle, one that's affordable, and one that can be fielded soon so that we can close the gap that Phil and Ed described up front between the completion of the shuttle program here and the next U.S. ability to carry astronauts to station. And so that's what I had for today. Thanks.
Thank you, John. We have some time for questions, so please wait for the microphone and please give your name and your affiliation, please.
Seth Bornstein, Associated Press. Multi-part for the 4 participants. I guess less so for John because you gave us some dates. First for Garrett, Elon before CCDev2 announcement said if he got enough money, he could do it, deliver in 3 years. Crew, is what you got, the $75 million, enough money, or failing that? Would also for the other 2 gentlemen from the less proven, the ones that are still a little newer to the field here, can you give us some time frames on, given what's come out now, when do you expect your first non-crewed vehicle to go into orbit? When do you expect the first crewed vehicle to go into orbit? So,
well, I guess I could start with answering your question about how long it would take, and the CCDev2 project is a 1-year project. We still believe that we can have a person in the Dragon, fly people, a crew Dragon within 3 years from right now. However, we would need additional support from NASA beyond the CCDev2 program to get us through those last 2 years, definitely.
Seth, thank you for the question. From our perspective, you didn't see my timeline, the really good one that I had up there? It's really good pictures. It was wonderful. We'll send it to you later. But specifically, a two-part question. One is that our vehicle has been in design and testing now for over 12 years, going on 13 years, so it's quite well known in terms of its design. We're flying on an Atlas V rocket, which has had 25 flights and it's going to have 40 before we go up. Our timeline is that we will be expecting to start our atmospheric tests in 2012 for the vehicle. We're expecting to then do suborbital flights in 2013 and do our first orbital flights in 2014. And by the end of that period, we would then be crewed and be looking to start our orbital transfer service. 2014, yes.
Seth, also, thank you for the question. All of our milestones are included in our Space Act agreement, including the dates for all of the objectives under CCDEV2. Follow-on work for orbital spaceflight will be continued under our founders funding, but if CCDEV3 or commercial crew follow-on is there, then we'll continue to seek that and accelerate our program. We don't release launch dates for orbital human spaceflight, and I'm not prepared to release those today. So.
Okay, right here.
Hi, Ken Kramer for Spaceflight Magazine. This is kind of a general question for all of you. I'd like to know about your business models. Do you think that there is a market to support more than one or two of these crew transport vehicles, given the way the economy is? You're going to have to find customers besides NASA. Do you think they're there, and what are you doing about it? Thank you.
I'll take a shot at that. I absolutely do believe that. Customers in the future, safety is the absolute. After that, it's going to be price, and customers will be picking based on price. And I believe there's a market for multiple suppliers launching people into orbit as long as the price is competitive. So, thank you.
From our perspective, I think, speaking words, anyone can say that there's a market. I think what we are doing is putting a lot of money behind it because we believe in it. And one of the reasons we do is that NASA is just but one customer, and taking people to space is but one activity from our vehicle. We're designing a vehicle that has multiple purposes. We think there are other things we can do in space. The servicing mission in LEO, for example, is a big market. Having a shuttle-like vehicle that is modernized by 30 years and has the capabilities to do new things gives us other markets that we can look towards in space. And we're very confident that those other markets, in addition to the NASA markets, will be able to support this program for many years.
I haven't had a chance to study our business plan. I've only been working in SpaceX for 2 months now, so that part I haven't covered. But I can tell you that in general, competition's a good thing, as we said right in the beginning of the press conference, and also having multiple vehicles that can get you access to space. I was in the astronaut office when we lost Columbia, and I know that we're able to keep supporting space station because our Russian partners stepped up and had the Soyuz vehicle, which is completely independent. So I think there's real technical reasons why you might want to do that, and I'll just leave it at that.
I have a couple comments to the question. First of all, I think there is a market beyond NASA. Space Adventures has certainly demonstrated that with their flights to space station to this point. And the work that Bigelow Aerospace is doing is demonstrating that. We took Mr. Bigelow over to the Farnborough Air Show last year and had an opportunity to meet with several of his potential clients who are primarily countries who want to have a space program but can't afford the infrastructure of their own dedicated space program. But they do have funds available to rent a piece of Bigelow's space complex for some number of months or years and have their own astronauts and do their own science. Quantifying that market and basing a business case on it is difficult. So we're closing our business case internally, assuming that the only thing that materializes is NASA business, and then this other business adjacent to that would be a significant potential upside as it materializes. More importantly than any of that, though, I think this affordable transportation to LEO, which is what this program is focused on, is a real enabler for continued utilization of ISS. The country has invested a tremendous amount of resources. The world has invested a tremendous amount of resources in space station, and it's important that we have transportation and servicing capability to get a return on that investment. And it's an enabler for exploration beyond LEO by providing an affordable transportation system to LEO. If we don't have an affordable transportation system to low Earth orbit, and it takes the preponderance of NASA's money to provide that kind of a transportation system, there won't be funds left to explore beyond LEO. So I think, in my view, the most important aspect of this is that as an enabler for ISS utilization and exploration beyond LEO. And both of those things are also important to Boeing as a company.
Right here.
Hi, Robert Perlman with CollectSpace.com for the 4 company representatives. Since this panel discussion started with comments placing the Commercial Crew Program into its context of the American space program's history, one of the things that's set apart the U.S. program has been operating in the open, letting the world watch both successes and failures. I wonder if each of you can comment on your company's approach to running an open program or not running an open program, and sharing your development and trials.
Okay, I'll start. All of our, we'll be working really closely with Ed and Brent Jett and his team, the NASA team, to work through all the detailed information that we've agreed to provide under our Space Act agreement. And so that's going to be a very fruitful program. We look forward to that. Secondly, as Blue Origin has more accomplishments and meets more milestones, we're going to be sharing more of our information with the media and the public, and we look forward to that. So, thank you.
Okay, Irene has a question. Go ahead, Irene.
Did you?
Oh, I'm sorry.
I'm not having very much luck today, am I?
You had a wonderful presentation.
Robert, you're seeing a good first-hand impression of how we do failure. So let me talk about a little bit on success. We're embracing NASA. We think that what happens here is a hybrid of bringing the past together with the future and being part of that. So my first answer would be I'm inviting you out to come visit with us if you want to come out and see what we're doing. We think being open, part of this is to inspire the country, to inspire the people, inspire the youth behind us to come into this program. It's not just about making money. It's not just about us going to space. It's about creating an industry in space. And to do that, we think we have to be in the open. We have to be able to discuss things and be able to admit the things that are difficult. Space is hard, and we know that. But if we can reach out to all those really smart people who have been part of this industry and bring them into our world, and if we can embrace the press as we're hopefully doing today, that will be very important to us. And it's up to you guys to be able to show that this is a really good program. It really is part of the things that could drive the future of our country. So thanks for that.
SpaceX is a really exciting place to be. I mean, it's just a really fun company, a great work environment, and we believe in sharing that excitement with everybody else as well. So for our launches of Falcon 9 and that first flight of Dragon, we had live webcasts and we had mission managers tweeting updates, and we plan to continue that type of communication as we go forward.
And I'll just conclude the row of speakers here. I would our openness, the way we'll proceed with things will be very similar to the way we have on Space Shuttle, Space Station, those kinds of programs in the past. So not anything real new or different there.
Okay, go to Irene. And then we'll go to the right.
Irene Klotz with Reuters. All of you are going to need to be putting together proposals for CC-Dev 3 when you're probably just getting started on your CC-Dev 2 work. And I was wondering if you, having this funding now in hand and assuming that you all meet the milestones to get the pay for it, what sort of funding levels do you think you might need from NASA for next year? Would you continue on toward development of the vehicles without NASA funding? And for Mr. Meyerson, how many people do you anticipate the Blue Origin vehicle being able to carry?
Okay. The number of people that are flying in the Blue Origin vehicle, that's in our Space Act agreement, which was released. There's 7 people to go to low Earth orbit. The amount of funding, I can't really, sorry, I can't really guess at that right now. We're really focused on our CC-Dev 2 agreement. We just got it. The ink is barely dry, and we're working hard on meeting all those milestones and exceeding NASA's objectives. As far as whether we're going to be continuing towards developing safe and affordable human spaceflight with NASA or not, absolutely. We have the long-term commitment of our investor, and this is our plan. This is a rare time in our history where our plan and NASA's plan intersect, and we're really pleased about that, and so we're really excited to be a part of it. Thank you.
We have been working on our program for a number of years without NASA funding and would continue to do that. We think that there are multiple markets for what we're accomplishing in space. Certainly No one's going to deny that NASA is the anchor tenant here, and it certainly makes it easier. It makes it more likely to happen, and to say otherwise wouldn't be truthful. But from our perspective, we are getting ready for the next award program, and it's one of those things. You graduate school and we're already into the next program before you even get started, and it's going to be a challenging race for all of us. I don't think we're at a point of discussing how much money that would be, because we don't really know what the size of the next program or the scope of the next program would be. But we're continuing to expect that we will be part of that, and look forward to contributing. And I think part of the other answer is that we all are. I think every company, and certainly my company, I can speak for us, that we're co-contributing alongside of NASA in these. We're investing money in each phase of the program, and we would also continue to look to do that.
Thanks, Irene. I guess my plate is really full with CCDev2, and you're talking about having to write the proposal for CCDev3. You're starting to stress me out here a little bit. So no, we haven't gotten those numbers ready yet, and we definitely want to continue our partnership with NASA as we go beyond CCDev2. And I can tell you, our company is founded to put people into space and advance human spaceflight. So we'll be there, and give us some time to work out the details. So.
Yeah. So I guess I would add that. So we've got a program laid out. I showed you the launch dates there, and so it's well defined what would have to be done during the next phase. What we proposed for CCDev2 really was just a slice of the program that was laid out. So as we work towards CCDev3, we would look at the next slice of that. I think the best way, everybody would probably agree, the best way to work on the CCDev3 proposal is to execute on CCDev2 and do a good job. And that's what I'm sure all of us will be focused on. Relative to would we continue without NASA funding, I'll tell you that our business model is dependent on government funding for us to continue. That's just the way we've structured it, the way it's laid out. If that funding was not there, we would continue at some very reduced level, I would assume, but it's certainly not at a level that would allow us to meet the dates that I've shared today.
Okay.
So, yeah, let me.
Wait, Ed has a
I do want to say that CCDev2 is the very beginning of this, or actually, it's the continuation of CCDev. It's the maturing of system elements. We have in our planning what we're going to go do next, and if you look at the overall design processes that these folks are going through, we're really at a early design state, something like a preliminary design, if not even earlier. And so the next phase is going to move us from that state that we're in at the end of next year, or the end of this CCDev2, or basically in the middle of next year, into the next phase, which is really more of a critical design kind of environment. We have to integrate the complete system, that is the ground, on orbit, the launch vehicle, and the spacecraft. And so we're going to be looking for concepts that are going to be doing that whole thing. You heard most of the four folks talk about how that is going to be integrated even in CCDev2 to begin with, but it's a beginning. So now we got to get to a critical design state, which is really a very important step, because that is, at that point, now you have a design. Now you got to do the next step, which is certify that vehicle. Make sure you can go fly what you designed. And as you go through certification, we're going to have lots of issues, lots of problems I'm sure we'll have to work through. And so that's a pretty heavy-duty period of time in order to get to that certification. Once all that is done, and the partners come forward and they say, we have a certified system, NASA has been working with them the whole time, we, as the program, will step up and say, all right, we think that this vehicle is all certified. At that point, we're going to go to the NASA community, the NASA agency, and look for approval to say we can now certify that vehicle. It's at that point we can go fly services. So in terms of when and how much money, I think a lot of that is still all being debated, but the idea is we would like to have services ready to go to the International Space Station in about the middle of the decade. Now, can we get there? You saw a number of possibilities that can get there. How much funding we have is all going to be dependent on how we can work through the things we have to get through, and then, of course, in the political realm. And so we have to work through all those. But the goal is to try, if we have enough funding, to try to keep competition as long as we can, and also to try to get services by the middle of the decade.
Okay. Now we're ready for the question here.
I'm Alan Boyle with MSNBC. I wanted to ask Rob, you mentioned that some of the milestones for suborbital flight are specified in the Space Act agreement. I maybe I misunderstood, but can you tell what the status of the suborbital development program is, when you expect to fly, and are you willing to match Mark's invitation for people to come visit you? I'm not that far away, so it won't be that much of a trip.
I realize that, Alan. And there will be a time, yes, that I'll match that invitation. The suborbital program, the tests of the pusher escape system are part of our CCDEV2 agreement. The other milestones that we're working internally with internal funding for the suborbital program are not part of that CCDEV2 agreement. All the milestones that are in our CCDEV2 agreement and all the dates, all the funding associated with those dates are public and in the summary that NASA released. So and they're available on the NASA website. So that's what I was referring to. So we don't release launch dates. It would be it's not something that we do. So okay.
Okay, right here.
Thank you. Hi, Tom Costello with NBC News. A lot of people, thousands of people, have lost their jobs or are losing their jobs because the shuttle program is being retired. Do any of you anticipate hiring any of these people over the course of the next few weeks, months, years? And secondly, can you address how you envision the astronaut role? Will you be hiring your own private astronauts? Will you be using NASA astronauts? But if you could get to the first point first, I think a lot of people are anxious about their jobs right now.
Okay. I'll take a shot at it first. First of all, I'm not going to, these are trying times. I'm not going to comment on the overall economy. I'll let Phil do that. We are. I'm gonna trust my customer to handle that one. We are hiring. Absolutely. We're looking for passionate, passionate, hardworking folks that are excited about spaceflight. I can say we've already hired a few folks from the community down here from the Space Coast. They're working for us up in Kent. They're doing terrifically. We're excited to have them, and we would. The space shuttle is the world's only reusable space system, and it's partially reusable. However, the knowledge and lessons learned that community has gained through that, those are people that are welcomed on our team. And so we're looking for the right folks, and we encourage them to go to our website, submit their resume, and see about getting on board. So thank you.
Well, I'll thank you for the question. I think from our perspective, I'd like to be a little bit more tangible. Not only are we thinking about it, we are doing it. We've opened up offices in Houston. We're in the process of opening up office here in the Florida area. We've held job fairs in many of the NASA centers around the country. We're going to continue to do that. We've put on more than 100 people on our team over the last year. We're going to continue to expand. One of the things that one realizes is that many of these skills and talents are needed for the future. And if you recall my high-tech presentation, this looks like a space shuttle, and it functions like a space shuttle and acts like it. And there are many of those jobs and skill sets that are necessary to turn around the shuttle, to move it, to get it back to flight, that we think are going to be a very natural progression over to our vehicle. Are any of us going to hire the kinds of numbers that we're talking about? I don't think so. But we're certainly going to be able to bring some of those people on board and many of the critical skills that are necessary so that NASA has the ability to look at other programs in the future. That's our goal, to make sure those skill sets remain in play either in our companies or somehow within the NASA centers. We're also reaching out to all the NASA centers that are applicable to this kind of program and asking them how we could work together. Is it possible for us to use their skill sets, their people, their facilities? Because it's not just people, it's being able to maintain the facilities that are critical to our country's future, and we're engaged in that right now, not as a theoretical exercise, as a practical one. If we're going to do what we're going to do by the time frame that we're talking about, we need to be able to realize one thing, that we're not going to be able to start from scratch. We have to be able to use the skill sets, the knowledge, the abilities of those great people around the NASA organization, in and out, contractors as well as government employees, to make that happen.
Well, I can tell you that SpaceX hired me. I used to work for the shuttle program. There's demonstrable evidence right there. But this is a very difficult time, and it's great to be back down here at the Cape. And I spent a bunch of time last night with people working in the shuttle and space station programs, and I know they're going through a lot of turmoil, and it's a time of transition. The people working in those groups are really top-notch people, incredibly talented, dedicated, hard-working people. with very unique skills. So I'm sure as we go forward at SpaceX and we take the next steps, SpaceX believes in hiring the best and brightest people from all over, and when there's a good fit, I'm sure we'll have some more of our brethren coming over as well.
And from Boeing's perspective, it's just a little bit different scenario. A goodly portion of the folks you mentioned whose jobs are tied to shuttle are Boeing employees. So during CCDev-1, we utilized the skills from shuttle and from space station, and also from the constellation programs that we're working in Huntsville. As we move, in fact, already we're transitioning those folks onto CCDev-2, those folks on shuttle. And we're working real hard to make sure that we capture the right kind of skills and resources that are going to be needed as we move ahead in the future. So we're already going down that road. You also asked about flight crew and how we'd be doing that. So we have some work to do with Ed and his office. You know, the transportation part of this, as Ed mentioned, is not ready to be worked out for some number of years possibly. Our internal baseline right now is that on the missions to space station, that one of the astronauts that is going to station would also be trained to fly the capsule, and so that we would work the flight crew that way. The test pilots for our initial flight, we're still working on whether those would be Boeing badged employees or NASA astronauts. So those are questions to be answered down the road.
Okay, this will be the last question.
Thanks. James Dean with Florida Today. Wondering if any of you are going to have an opportunity to meet with the president tomorrow, given that commercial crew got off the ground on his watch. And also just wondered if you know, in talking about reducing and minimizing the gap, can you just offer a little bit of a big picture reminder of how you are going to do that? In other words, reducing it from what options were out there. The gap will end whenever you fly, of course, but it sounds like 2014, 2015 is the best case scenario. Is if it slips from that, is the nation really much better off than it might have been under Constellation?
I'll start again. Thank you for the question. I have my family here with me to go watch the launch tomorrow, and I would be ecstatic to meet the president. So if that's an invitation, but I would love to do that. Love to have that opportunity. Related to the gap, I think the best way we can close the gap is stay focused. And as an earlier questioner pointed out, I mean, we're not as far along. We haven't demonstrated a system like the Falcon 9 and Dragon, but we're going to continue to stay focused on our path. We're going to work our partnership with NASA and stay focused on meeting these milestones step by step, and we hope to, when we have a system to field, we'll know it's ready because NASA and we will be able to conclude that it's ready to go and put people into space. Okay, thank you.
James, hi. Thanks for the question. One of the things I think that we'd like to point out about this program is that it is a milestone-based program, and that's important because we get paid after we perform. And I think one of the hallmarks and one of the really strong parts of the commercial crew development program is that there's co-investment and there's performance milestones. What that means is that if any of us are unable to perform their milestones, there's a protection for the government that they don't spend the money that would have been set out to do that. As it relates to the gap, that's a method by which it self-adjusts, meaning that those companies that are successful will continue to move forward, will continue to get funding, will continue to advance, and those who are not won't get paid. And there's a balancing mechanism there. I don't think we can answer what this is compared to other programs or what other programs might have been. We don't know and we'll never know. But I do know that by virtue of the nature of the program, we're highly incented to produce a safe, affordable vehicle. And if we don't, then all of us who don't are going to be exiting the stage. And from our company's perspective, we're very much focused on doing that. We have all our milestones planned through flight, and we know exactly what we need to do, and now it's a time for execution. Regarding the president, I'm sorry that I can't tell you because I'm sworn to secrecy about that. But we look forward to seeing him here, and we do think that's a very nice gesture and comment on his ability and interest in the space program by him coming down here with his family.
Yeah, I have not received Mark's super secret presidential invitation, so I guess I'm out in the cold. We did actually get to meet the president after we came back from STS-132, my last flight on Atlantis. We got to go down and visit him in the Oval Office, and I can tell you he's an extremely large supporter of spaceflight in general, and and he believes in the commercial crew concept as well. He sees that he understands the value and a valuable role that NASA has played over the course of its existence, and as not only in the science and technology it generates, but also the impact it had upon all of us, and many of us sitting up here at the table do what we do today because of being inspired by what NASA did in the past. So he wants to make sure that NASA continues to lead, and as far as the shrinking the gap, that's something we're all trying to do. After the next 2 shuttle flights, we won't have a capability to get humans into space on an American vehicle. We're in a partnership with the Russians and the other countries on the space station. We're not being a good partner if we don't come to the table with our own capabilities. And so I think we're all dedicated to shrinking that gap as quickly and as efficiently and as safely as we can.
I'd add just a couple comments to your question. I think I'm hopeful that as we go through this launch and the next launch and complete the shuttle program, that the awareness of the fact that we don't have a U.S. capability to transport astronauts will gain momentum, and that so there'll be momentum within the congressional process to ensure that we have the funding that's required to execute the schedules that we've shown today and are able to shorten the gap by that method. The other thing that you asked a little bit about, if it goes longer, would it not be any different than Constellation? I would say a couple of things about that. The vehicles of Constellation were designed for exploration beyond LEO and also could do the LEO job. So they might not be as affordable, probably wouldn't have been as affordable as the systems that we're working on that are primarily focused on just LEO, low Earth orbit. So we can have simpler systems, smaller rockets, that kind of thing. And as I mentioned earlier, by lowering the cost of transportation to LEO, there are funds available for developing vehicles and doing exploration beyond LEO. So I think there's more figures of merit to judge the comparison than just the schedule would be the comment.
See, I guess I'd like to say that the gap is a gap in capability, and so we have to go work that out. What John said was very good about the Constellation program and whatever falls from that, now that hopefully NASA will be able to go do exploration. That's the systems that get us beyond LEO. So if we get affordable systems from these folks for LEO, we have more money to go spend on going to do more exploration. And I grew up in the late 60s and early 70s, and when the Apollo program ended in '72, I was like one of the few kids in class that would ask the teacher if they could put on the TV station, which always had the Apollo stuff live, it seemed like, at least a little bit of it. And after it ended, I'm like, well, what's next? I was only not even a teenager yet. What is next? What are these guys going to do next? And it was quiet for a few years. But there wasn't any change in my desire as a teenager now and someone going into high school to want to go study engineering or want to go study technical stuff. I wanted to be a pilot and I wanted to be an engineer. And so it wasn't, that really got codified when we started seeing Enterprise and its missions. And so that was the icing on the cake. But the inspiring fact had already happened, and that was that we were leaders in space. We were the first ones to the moon. We were the first ones to put the Space Lab system up. And so to me today, the gap is, there's a technical gap we got to go close, which is getting our American astronauts into space. The second thing is the gap to continue to inspire the fact that the next generation of kids who are in junior high and high school today are going to want to go be high-tech jobs and go work in space in the future. That's the gap I'm most concerned about, and I think by doing this CCDev activity and the following activities, we are showing very clearly that there is a future for folks who want to go pursue those kind of careers.
Okay, for more information on CCDev2, please go to the NASA website at www.nasa.gov. Thank you very much for your questions and for attending today. That concludes our briefing. Thank you.